We have just started the recording. So we were discussing about bitwise operators. Yesterday, like the discussion was going on for triple right shift operator. To understand this triple right shift operator, some prerequisites are required, right? So not exactly the prerequisites. We use a different data type for this triple right shift operator. So first of all, let me give you some briefing about this triple right shift operator. So the representation is very simple. The symbolic representation is going to be like triple arrows. I mean, we can say that the triple greater than symbols, right? The arrow symbol or the triple greater than symbol that we can use to represent a triple right shift operator. This is the symbol that you can use to represent a triple right shift operator. Symbol. Right? Unlike the right shift operator, which is used to perform certain operations, in the triple right shift operator, we are not going to consider the MSB part, I mean the most significant bit part. Right? We know what is MSB. MSB is the most significant bit, and if you talk about the right shift operator, the actual right shift operator, right? We always assume we always going to consider the MSB part, but in the triple right shift operator, whatever the value that is there in the MSB, right? We are going to use the 0 in place of MSB. The MSB or the void space, the empty space that is getting created will be filled with 0. No matter whether it is a negative number or whether it is a positive number, the void that is getting created will be filled with 0. That is the second requirement that we need to look after, right? So I can say that the void space or the empty space that gets created while performing the shifting we should always fill it with 0. No matter whether it is a negative number or the positive number, the void space should always get filled with 0. And this triple right shift operator can also be pronounced or can also be called as unsigned right shift operator. Right shift or the logical right shift. But you must understand one thing. So whenever you are trying to represent this triple right shift operator, the minimum by default you should be using the integer data type, right? By default the system is going to consider the integer data type. What does it mean, sir? If you ask me, I will explain. By default the system is going to consider the int data type. I can say int data type. So we already know the size of the int data type. So the size of the int data type can be what we call it as the size of the data type is 4 bytes, right? So in data types, internal register or internal the size register is 4 bytes. The size is 4 bytes. So 4 bytes can also be called it as what is a combination of is a collection of 32 bits. Each and every byte is going to, each and every byte is a collection of 8 bits, right? So 4 bits is nothing but 4 into 8. So it is a collection of 32 bits, right? So whenever you're trying to perform any operation by using triple right shift operator, for example, let us take that I have a number 5. And I want to do the triple right shift operation with 1. This is my number and I want to use the triple right shift operator, right? And I want to shift this internal part of the number 5 to one position to its right side, right? So what happens internally is a registry will be created. In the RAM, internally there will be a RAM. Inside the RAM, a registry will be created. So what does it mean to be a registry? Registry is nothing but the bits, the spaces, the memory allocations. The memory allocation will happen internally. How the memory allocation will happen? The memory will be allocated for the int type. Int type means 4 bytes. 4 bytes in the sense the combination of 32 bits. Let us say that this is 1 byte. If you say this is 1 byte, 4 byte is going to be represented like 1, 2, 3, and 4. 4 bytes. And internally we know each and every byte is the collection of what? 8 bits. Again, each and every byte is going to be divided into 8 bits. This is how the integer data type will get represented inside the memory, and we completely call this as a registry. Right? Let's count this space. 1, 2, 3, 4, 5, 6, 7. Okay, let me add one more box. So internally this is how it gets represented. Let me delete this. Okay. After deleting this, let me rewrite this. Likewise, each and every byte will be, each and every byte is a collection of 8 bits, right? So each and every byte is going to have some spaces. These are the spaces. So each and every space is representing, each and every block is representing a single bit. As simple as that. I hope the counts are, numbers are correct. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, one more. Right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is how the spaces will be created inside, and I have taken the number 5. Now please try to pay some attention here. I have taken the number 5. Number 5 has been taken. So let me take a copy of this for future reference. Okay, right? So how 5 can be written internally? Right, when you want to represent 5 in the binary form, the representation 5 can be represented like 101, 101, and all the remaining blocks will be filled with 0. All the remaining blocks are going to be filled with what? Are going to be filled with 0. Okay, let me reiterate. What I was saying is triple right shift operator. Whenever you are trying to perform any operation using triple right shift operator, nothing but when you try to perform using an operation by using triple right shift operator, by using this symbol, internally the system is going to consider the int data type, integer data type. By default, the system is going to consider integer data type. And again, how the integer data type will be represented inside the system, right? So every data type, when you use any data type, it is going to have some memory allocation, isn't it? For integer data type, the memory allocation is the size of the integer data type is already given as 4 bytes. So each and every byte, if you say 1 byte is nothing but the collection of 8 bits. Right? If I say 4 bytes is what? It is a collection of 32 bits. Right? Each and every register, each and every block is representing 1 byte, and inside each and every byte, I have created 8 spaces, and each and every space is representing 1 bit. As simple as that. Right? Why it is considering integer data type? It is designed in such a way that whenever you are trying to use triple right shift operator, it will consider integer data type. This is how the integer data type will get represented inside the system. For number 5, this is how the values will get allocated internally. If you convert this to binary, again if you convert this to decimal, you will get the answer 5. Because these values have no significance. Everything is 0, isn't it? So no significance. Right? So the memory got allocated like this, and what we are doing, we are trying to do shift operation, triple shift operation. Triple shift in the sense, by shifting it only once. The number that we have used here what is 1, right? So one number will be shifted. I mean each and every number will get shifted to one position to its right. That's what it means. So I can say like, let me take the same block. Not all the values are not getting copied. Okay, let me redo this once again. One, two, three, 4, 5, 6, 7. Okay, 2, 3, 4. Okay, we got it. So we are trying to do triple right shift. So this is what we have. The number 5 is getting a triple right shift to the position 1. This is talking about the position. It means each and every will be shifted to one position towards its right. So this particular one will not have any space, right? It will be what? It will get disappeared, right? And the next bit is going to take this place, 0. And the next bit is going to take this place, 1. Likewise, I can fill everything. Everything will be filled according to the shifting, according to the right shifting. Because we are right shifting it only once. That is what I have said once. Right? So each and every block, each and every value will be right shifted to one position towards its right side. Right? After doing all this, don't you think that there will be one empty space will be created here? Right? One empty space is getting created here. This is the empty space that is getting created, right? So what it says, whenever an empty space is created, we call that empty space as a void. Fill that void with what? 0. That is what I mentioned here. Fill that empty space with what value? With the value 0. Right? So I am doing the same thing. I am filling the empty space with what? I am filling the empty space with 0. Right? And after doing this is the new set of registry that we have got after performing the triple right shift operation. Right? Now convert this directly into the binary number. Right? What binary number we are going to get if you do the conversion? Very simple. The answer is going to be what? It's 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. Right? So these zeros have no significant effect. Just take the power of 2 that is pointing towards the 1th bit. Right? So 2 to the power of 1 is what? 2. The answer is 2. Right? If I do 5 triple shift 1, the answer is going to be 2. Right? So let us check this out whether the answer is 2 or not. I am opening the online compiler. Right? So here let us give a meaningful name. Triple. You can give any name, but meaningful name is always recommended. So triple right shift operator. Right? So here I am taking 5 is getting triple right shifted to 1th position. The answer should be 2. Answer is 2. Why answer is 2? So this is what the things are happening internally. Right? So we know, okay, it is okay because it is very much visible. Right? Anyone with the eyes can say that the answer is going to be 2. Right? Because only one shift is happening. Right? Obviously, after the conversion, after doing the right shift and after the actual conversion, the answer is obviously going to be 2. But the question is, when you try to place a negative number here we have used the positive number. Right? But when you do the same operation with a negative number, let us say that if I am taking -5. When I am taking -5 and if you see the output, right? So the number is very big here. Now we will have to understand why we are getting this much difference. For the positive 5, the answer is straightforward. Why it is straightforward? Because internal conversion after learning about, after getting to know the memory allocation, after understanding the internal conversion, so we get 2, right? It is visibly seen, right? Why for the negative number? Why for negative number? The answer is very huge. The difference is so big. We will understand it now, right? Same concept I'm trying to do with the negative number, right? So previously I have taken the positive number, and now I am trying to take the negative number, right? Are you with me so far till now? Just type yes in the chat box. Are we good so far? Okay then, okay then. Okay, Darshini, okay, Ganesh. Yeah. So for the positive numbers, we have no issues, but we are not finding any issues for the negative number, but we need to find why the difference is very huge. Why the answer is this. So let me take the same program, right? This time we will analyze it in a different way, right? This is what the program is. I'm just copying it and I am pasting it in the paint box, right? This is the program, right? So after the execution, right, we get the output is like what? Output is like this, a very big number. Output. So let us analyze it, or let us try to perform the execution like a beginner, right? So this is the source code. Obviously, we all know, right? Internally, we need to take care of. The source code has to get saved with .java extension. Triple write operator is the class name. Along with the class name, just give .java extension. This is the rule. This is how you will be saving the Java file. Rule. Right. Secondly, the compiler will come into the picture. This is the compiler. The job of the compiler is to ensure that the code that the developer has written or developer has drafted has no errors. It will ensure that the code is error free. Right? That is the job of the compiler. If there are any errors, it will ask you to correct. If there are no errors, it will convert this source code, or it will convert this .java file into what? .class file. Very simple. .java file will be what? Will be taken by the compiler. Compiler will it is going to take this .java file, right? And what it is going to do with the .java file? It is going to convert this .java to the .class file. Right? When you see .class file, it means okay, your source code has been compiled successfully. If the source code is not compiled successfully, the .class files will not get generated. If it is getting generated, it means you have the successful source code file compilation. So .class file will get created. Only thing, very simple. .java will be converted to .class, as simple as that. See my previous videos, you will understand better, and in the future we will also going to see these things once again in the OOPS concepts. So no worries. And now the JVM will come into picture, right? So JVM, the job of the JVM is what? It will, all the .class files will be loaded inside the JVM. Okay? So since this is the .class file, it has to get loaded inside the JVM. As soon as the .class file is getting loaded inside the JVM, a main thread will be created, right? What the main thread will usually do? Main thread will try to get access to what? It will get access to the main method, right? It identifies the main method. Yes, main method is, and all the instructions inside the main method will get executed, right? How many instructions are there here? Only one instruction is there, right? So what inside only instruction is what? The only one instruction is system.out.println, right? Inside the system.out.println, we have right? We are trying to evaluate an operation. We are trying to perform an operation. What operation? Triple right shift operation. So this is the operation that we need to perform, right? So what now? What the JVM will do? I have already said, whenever it sees the triple right shift operator, right, a registry will be created or memory will be allocated considering the integer data type. Triple right shift means by default the computer will allocate memory according to the integer data type. What is the size of integer data type? 4 bytes. 4 bytes. This is 1 byte. So to make it very clear, so this is 1 byte. This is another byte. This is how the 4 bytes of data looks inside the memory. Right? Each and every byte again internally will be divided into many parts, isn't it? 1, 2, 3, 8 bits of memory. 1 byte is representing collection of 8 bits. 7, 8, right? So instead of doing this, I can do like this. So collection of 8 bits. Let me remove this. Now, try to understand this. Same thing, but this time we are using a negative number. Previously it was a positive number, right? But now we are using what? We are using a negative number, right? How to convert the positive? First of all, we need to represent the negative number in the form of binary, right? We already know a negative number can be represented. When you want to represent a negative number, you need to do what? You need to do 2's complement. You need to do 2's complement. Positive number. So what is the positive binary number representation of 5? Right? This is the positive binary number representation of 5. Very simple. This is what the positive binary number gets represented, isn't it? Everything will be 0. Everything will be 0. 0, 0, 0, 0, 0, 0, 0, 0. 0, 0, 0, 0, and the last three last three bit sets are going to be 1, 0, 1. If you convert this directly you are going to get the positive 5, but I want to ensure that I am getting negative 5, right? So negative 5 can be represented in the form of 2's complement. How do you actually do the 2's complement? First of all, you will do the 1's complement, right? What is the 1's complement? We know that 1's complement is nothing but flipping of bits. Flipping is very simple. If you find 0, replace that 0 with 1. Just toggle it. Toggling means if you see 0, replace it with 1. If you see 1, replace it with 0. This is what we call it as the 1's complement. Just toggling the bits. Or I can say that just switching the bits. So let me take another color. So here 0, 1, 0. I perform the toggling. This is what we call it as what? 1's complement, right? After doing 1's complement, we need to do the 2's complement. 2's complement is nothing but adding 1 to the 1's complement. 1's complement plus 1 is going to give you what? 2's complement. So I will add a 1 here. That's it. I will add a 1 here, right? If I do some calculation, right? If I do this, I will get what? I will get the value for 2's complement. Everything will be 1 again. Right? So I am saying that this is representing -5. This is representing -5. Let me create blocks for the better understanding. I am separating each and every bit with block. Internally, this is getting represented as -5. I will tell you why it is -5, and we have already seen this in the first video. And again, after completing this, I will ensure, or I will give you some tips how to create a negative binary number with the help of 2's complement. You will understand that. So this is representing what? This is representing -5. This is how the -5 will be represented inside the memory, right? Now the question is, what was our question? -5 should be triple right shifted to 1, right? It means This is the value of -5. It should be triple right shifted. I mean, right shifted to ones, triple right shifted to ones. So each and every bit is going to push you towards its right side of the bit, right? One position will be moved towards the right side. So this one will be disappeared, right? This one will have no place to go, right? This one will be disappeared. This one will be disappeared, and the remaining things will be intact, right? So excluding this one, I can write. Let me write it like this. Provide conclusion. Let me take this. Right. So this one will be right shifted, right? Right shifted in the sense it will have no spaces to be held, so it will be disappeared. It will be overflowed. I can say the remaining entries will be filled. So this will take this position. This will take this position. This will take this position. If it keeps taking like this, so the filler can be like what? 1, 0, and everything will be 1. Everything will be 1. Everything will be 1, and there will be one void space will be created in the beginning. It's a space, empty space, right? So in the beginning, what I have said, the empty space should be filled with what? We should always fill it with 0. Fill the empty space with 0. Right? Now convert this big binary number into decimal number. If you do the conversion is like, just keep adding 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and like that, right? 2 to the power of 31. If you do the conversion, you are going to get this value. As simple as you will be getting this value. If you have time, you can do this. This is the value that you get. Now you are able to understand why the value is so big for triple right shift operand. This is the value that you are going to get if you do the conversion. Right? If you consider this everything as a binary number, and if you do the decimal conversion, this is the value that you are going to get. Right? That's why there is a huge number of difference between the negative number and the positive number. Positive number means very simple to understand, right? Just shifting will take place, right? After the shifting, if you do the conversion, you get a value. The value can be converted very easily because the remaining numbers are going to be same 0. But for a negative number, firstly you need to do 2's complement, right? Doing the 2's complement is going to increase the magnitude of the number. After doing the 2's complement, you are filling the space with 0, right? After filling the space with 0, and you are doing the conversion, so the value is going to be a huge value. That's the reason why we are getting the huge amount of value for the triple right shift operator. Then and the question is where we will be using all this. That part I will explain you, but you must understand what are the things that is getting happened internally when you do the triple right shift operator. That understanding is mandatory. Once you understand that, we will solve a lot of problems by using all these bitwise operators. So this is making some sense, right? Just try to understand. Okay, for the triple right shift operator, for a negative number, what I need to do? You need to do the 2's complement. You need to find the 2's complement, and on top of 2's complement, you need to perform the right shift. Right? After finding the right shift, after allocating spaces for all the bits, right? You need to convert this number to the direct binary number. Convert this binary number to the direct decimal number, and this is the value that you get. This is the value that you are going to get. Same value that we have got by doing it in the Java program. As simple as that. Making sense? Right? And one more thing you need to notice is this triple right shift operator is a special operator where you will find only in Java. In Python, this operator is not there in Python. I can say that this operator is not supported in Python. Why it is not supported in Python? You will understand that. But the Python people, when they developed Python, right, they did not consider the concept of triple right shift operator. In Java, it's there, and there are a lot of uses when you go and start using the triple right shift operator. But where we are going to use that, I will explain. No worries about that. This is the basic understanding that you must know what are the things that are getting happen internally when you start See, if the program is very simple, it is just like -5 double shift operator 1, but the value is very huge. You need to understand how this value is getting generated, why this value is getting generated, and where are its where are the where use cases, that I will explain it. There are a lot of problems that we can solve from this, right? Now we will understand the difference. We have understood what is the right shift operator, and this is the triple right shift operator. What are the differences? I will specify it here. Then we will go for complement operator. After completing the bitwise complement operator, all the topics will remain covered. Right? We can start discussing on working out on some problems. Trust me, those problems are going to help you a lot. Even the experienced people, they will find it very difficult to solve those problems, but I will give you the ways and approaches to solve some problems on top of bitwise operators. Shall we proceed? Are we good to go? Type yes in the chat box, because since I am only talking, I need to ensure that we both are on the same page. That's what. Are we good? Okay, Ganesh. Now let me draft you the differences between these two operators. Let me take a different color. What are the differences between? You may, there are less chances for you to encounter this question in the interview rooms. But if you understand these differences, it will be easy for you to solve problems. That's the reason why I'm helping you out with these differences. So differences between the triple right shift operator and the what? Very simple differences between these two. This is right shift operator, right? This is triple right shift. And one more question: is there anything like triple left shift operator? This thing is not there. When I do this, this is not there. There is no concept of triple left shift operator. It's not. If you try to execute this, you will get error. The Java will not recognize this. So say triple right operator is there, but triple left operator is not there. Only the scope is there only for the triple right shift operator. So this, instead of writing it like this, I can write difference between right shift operator, triple right shift operator. Triple out. Okay, these are the symbols. When you say right shift, triple right shift, right? So the first difference is the right shift operator as can be pronounced or can also be known as is also known as arithmetic right shift, or we can also say the signed right shift operator. Why signed right shift operator? See the yesterday's videos, you will understand. Let's repeat the video once again for the better understanding. Signed right shift operator. Because we will consider the MSB part, most significant bit will be always considered. If it is 1, we will replace the pillar with 1. If it is 0, we will replace the pillar with 0. But that is not the case with the triple right shift operator, because whatever the fillers or whatever the empty spaces that is getting created, the empty spaces will always be replaced with 0. Right? That is why it is also called as logical right shift. So, known as logical right shift or unsigned. There is no why unsigned, because every time the MSB is getting filled with 0. If it is a signed, we will be considering the MSB. So sometimes depending upon the sign, the MSB will be filled with 1 if it is a negative. But here that is not the case. Whatever the void or whatever the empty space that is getting created in the MSB, the empty space is always getting filled with 0. That's why it is called as unsigned right shift operator. Right? And the explanation is like it is always the MSB, is always the MSB that is used as the filler, I can say. That is used as a filler. Here I can say that 0 is always used as a filler. The last point is the sign of the number. We will always consider the sign of the number, signature of the number. Signature in the sense the symbol of the number. If it is a positive, we will consider the positive. If it is negative, we will consider the negative. So I can say that the sign of the number is always preserved. Here, the sign of the number is never preserved or not preserved. So these are the main key differences between right shift and triple right shift operator. Right. So this triple right shift operator, I can also add like Python does not support triple right shift. Why Python is coming here? Just to show the difference, nothing else. Python does not support triple right shift operator. So all the things about these operators are being discussed on top of the memory perspective. Right? Internally, how the memory is getting allocated, how the registries are getting built by the RAM. Right? When you want to save a number, right? It is not just like the saving the number, but internally it's this many things are happening internally. A registry will be created, or a bits will be, the spaces will be created according to the data type that we are going to place, according to the data type that we are going to mention. Based upon the data type that you are going to mention, so many things are getting happen internally, right? So we are just understanding how the memory is getting created internally by using Java. This point is going to be, it will make a lot of sense after completing Java. After, or I can say, after completing data structure, this point will make a lot of sense, right? So don't even assume that, okay, the Python is also a popular language. Yes, Python is also a popular language, but the thing is, right? So all these languages, Python, Java, right? They are just a kind of language that is going to be used to communicate with the system, right? The syntax of Python is easy, but the Java, when you learn Java, learning Python becomes very easy. It's not like vice versa. If you learn Python, Java will not become easy. But if you learn Java, learning Python will become easy, very easy. Learning Python is going to be like a cakewalk. So syntax wise, Java may sound difficult, but trust me, if you learn Java, learning remaining languages in the market is going to be very easy. I'm not saying this because I'm teaching Java. Even I have also I'm also good at Python. But in comparison, I can say that Java is a better programming language for the beginners and for the experience as well. So let us go back to our topic, and now one bitwise operator is left out. Complement operator, bitwise complement. I can use this place. What is the symbol for this? Already discussed. Both is simple, very easy. This is what the symbol is. You can find this symbol like next to the number one in the keyboard, in the QWERTY keyboard. Bitwise. Very simple. When I say, if I have a number like integer n equal to 2, or let us say that I have a number like n equal to 2, right? If I just do this, what the output, what could be the expected output? Let us do this in the program. For example, if I just give number 2, okay, the answer is going to be 2 because the same 2 gets printed in the console. But if I do complement of 2, if I use this, right, we get the output as minus 3. So this is not the minus symbol, this is the complement symbol, like a like a tilde symbol. This is minus. It's not minus, it is a symbol, tilde symbol. When I do the complement of 2, when I say complement of 2, it is nothing but adding a number, adding a precedence, like I am just adding a symbol before the number. The tilde symbol I am adding before the number. When I do this, the output is becoming minus 3. Why it is minus 3? We will understand. Same program, let me take. Internally, what is happening? How the memory is getting allocated? That things we will understand. Complement of minus 2 is giving out. See, complement of 2 is giving minus 3. How the 2 can be represented in the form of binary number? Very simple, right? So, and one more thing. Here by default you can have like 1 byte of memory. But when you talk about triple right shift operator, by default is going to consider integer data type. That is not the case. Such case is not existed in the bitwise complement operator. You can take any byte size. So in this example, I am considering 1 byte. So 1 byte is the collection of what? Collection of 8 bits, right? So 8 bits in the sense internal representation is like this. Right? 2 can be represented as what? 0, 0, 0, 0, 0, 0, 1, 0. Right? When I say complement of 2, right? When I say complement of 2, what should happen internally? Internally, all the firstly we have to find the 2's complement. Complement of 2 is nothing but first you need to find the 2's complement. Before finding 2's complement, we need to find 1's complement. So the equivalent 1's complement for this binary number is going to be what? 1, 1, 1, 1, 1, 1, 0, 1. This is the 1's complement. Right? After finding the 1's complement, find the 2's complement. Right? So here we are not going to directly find the 2's complement. So we have just flipped the number by using 1's complement. Right? So the first bit, if you look at MSB, so the value of MSB is what? The value of MSB is 1. So 1 is nothing but 1 is always going to represent what? 1 is always going to represent a negative number in in binary system. Let me clear out this confusion. So before even proceeding with this, let us try to understand this thing. Let me make this concept very clear. If I have 5, for example, if I want to represent the number 5, n equal to 5, I want to represent number 5 in the form of binary number. At the same time, I want to represent number minus 5 in the form of binary number. I want to represent this in binary numbers, right? So when I want to represent a number, when I want to consider its symbol as well, symbol in the sense here the symbol is what? Negative symbol, negative signature, right? We call those data types as signed data types. When I say signed data types, the data types that are going to support both the positive number as well as negative number. Right? When I say unsigned data type, the data type is going to support only the positive number. So I want to use a data type. Which data type I want to use? I want to use the signed data types. In Java, all the primitive data types except Q. For example, if you take int, you take byte, you take short, and if you take long, all these data types are what? Signed data types. Right? Very simple, guys. If I for the signed data types, let us take a simple memory block. For example, the size of byte in Java is what? Size of byte is 1 byte. 1 byte is also called as 8 bits, or we can say that collection of 8 bits. Right? So the internal data, let me create some space. Let's 1 minute. So let's focus here. I will clear you some confusion. Okay. I want to represent number 5, the decimal number to binary number. At the same time, I want to represent -5. Right? In Java, all the primitive data types, the most potential data types that you can use is integer, int data type, short data type, or byte data type, or long data type. Each and every data type is going to occupy some bytes of memory. Right? Let us go with byte data type. When you say byte data type, right, this byte data type is going to occupy 8 bits of memory. It is going to create a space of 8 bits. Very simple. It is going to create a space of 8 bits. If you want to store the number 5 by using byte data type, how many? 1, 2, 3, 4, 5, 6. Okay. So this is a byte data type. If you want to store number 5, positive number 5. In this byte data type, very simple, right? So this is going to be 0, 0, 0, 0, 0, 1, 0, 1. Very simple. This is how the binary representation of number 5. But you must understand one thing. All these data types are signed data types. Signed data types. When I say signed data types, it means the leftmost bit, the extreme left bit means okay. The extreme left bit is going to talk about what? It is going to talk about the signature. Right? This particular space, this particular block, or this particular bit is going to talk about what? It is going to be reserved for signature. Sign, I can say. Right? When it is 0, it means a number is a positive number. When it is non-zero means the other number, other potential value for any bit can be 1, right? When it is non-zero or when it is 1, the number is going to be a negative number. Very simple. The most significant, we can call this part as what? Most significant bit, MSB. Right? When you see the MSB as 0, this particular bit is reserved for the symbol, or you can say the reserved for the sign. Right? When you find 0 is for positive number. You can say that okay, it is a positive number. When you find 1, it is a negative number. So this directly, by seeing this, if you do the conversion, you can clearly say that it is the positive 5 number. Like this binary number, if it is converted to decimal, then our value is going to be 5. But if you want to represent -5, how the representation can be? To represent -5, I need to make use of 2's complement. Try to understand. I need to make use of 2's complement. What is a 2's complement? First find the, for example, -5 is there. First find the binary equivalent for 5, positive 5. The binary equivalent for positive 5 is what? 0, 0, 0, 0, 0, 1, 0, 1. This is the binary equivalent of positive 5. If I want to find -5, I need to do 2's complement. 2's complement is first to do 1's complement. First to find 1's complement. 1's complement is flipping of numbers. If it is 0, toggle it to 1. Just toggle the numbers. If it is 1, toggle it to 0. Numbers are flipped. This is called as 1's complement. Then after finding 1's complement, add a 1 to this number. You will get 2's complement. right? So 2's complement of this number is 1 1 1 1 1 0 1 1. If I add 1 to this is what I get. What I am saying is this value is representing -5. Can you show it? Can you prove that, sir? I am saying this value is representing -5. How I am saying? I already said that the rightmost bit is reserved for, right? This rightmost most significant bit is reserved for what? Is reserved for the signature. This bit is reserved for what? This bit is reserved for signature sign. So it has the value 1. 1 means negative sign. 1 means negative sign. Right? Now let us do the conversion. Right? Let me take the same number here. So I am writing this here. 1 1 1 1 1 0 1 1. I said this is for negative sign, negative value. Right? Now perform the conversion. This is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. Right? 2 to the power of 7. What is the value of 2 to the power of 7? 128, right? Correct me if I am wrong. 128, not positive 128, minus 128. Because I said the leftmost bit or the most significant bit is reserved for the active. So minus 28, minus 128 plus 64 plus 32 plus 16 plus 8. This will not be evaluated because it is 0, right? Plus 2 plus 1, right? So minus 128 plus, do the calculation, 64, 74, 84, 94, 96, 06, 112, 120, 123. After the conversion, you will get what? Minus 1. Making sense? Can we say that this is equal to minus 5? How it is minus 5? Why this conclusion is there? Because of this 2's complement. Right? When you do 2's complement, the positive number is getting turned into a negative number. Right? Why it is getting turned into a negative number? Because the most significant bit is going to be considered as what? The most significant bit. The leftmost bit, the extreme left bit, is going to be considered for the signature. If it is 1, negative. If it is 0, positive. Right? If you apply the same logic and if you do the decimal conversion, right, you will get minus 5. Making sense? Why we are using MSBs, why we are trying to find 2's complement just to get the negative number. Same way goes for, we have a number like if n equal to 1, n equal to minus 1. If I want to like do the decimal to binary conversion for n equal to 1, right? Very simple, 0 0 0 0 0 0 0 1. I got, this is the binary representation of n equal to 1. But if I want to do the same thing for n equal to minus 1, I need to find 2's complement. Right? Before finding 2's complement, for this number I will have to find the 1's complement. 1 1 1 1 1 1 1 0. 1's complement is done. Add a 1 to it to get the 2's complement. So 1 1 1 1 1 1 1 1. This is 2's complement of the number, right? So the most significant bit is 1. Apply the values. Apply the values. Convert it to the binary. There you get minus 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. Right? If you do all this, don't you think you will get 127 plus minus 128? Minus 128 plus 127 equal to minus 1. Can we come to a conclusion that finding the 2's complement is going to give the negative number? Why it is going to give the negative number? You as a developer, you need to consider the MSB. This MSB will be considered as a negative number, negative sign. Just put negative sign and do the evaluation, you will get minus 1. Making sense? Just type S in the chat box if it is clear now. Why we are going for MSB and how to find the negative number for a given number. If it is clear or if you have any doubts, you can ask me now. Right? Because this understanding is important to understand the bitwise complement operator. That's the reason why I have just explained to you what is how to find the negative value or how to represent the negative number in the form of binary. Right? Why they call it as signed data types? Because of this they call it as signed data types, because this particular data types should be capable enough to store both positive numbers as well as negative numbers. If it is not a signed data type, you cannot store the negative numbers. As simple as that. All you can store is the numbers that starts from 0 to 0 to some number which is a positive number. When you say signed, it means the number can be negative numbers to the positive numbers can be stored. Right? Internally, you will design in such a way that you will take the most significant bit, you will consider the most significant bit, and at the same time you will find 2's complement to find the negative of a particular number. If you want to find the negative of another example, if you want to find negative of -4, first you will find the binary equivalent for 4 number, then you will do 2's complement, you will get negative number. Making sense? Right? So far, we will keep it very simple. We will stop it here. Tomorrow we will complete this MSB thing. We will complete this complement operator. Then we will start working out some problems on top of this bitwise operators. Right? Then we will proceed with the remaining topics. What are the remaining topics? Hexadecimal, and we have octal number representation. We have hexadecimal number representation. After completing that, we will start data types. Right?